Hello and welcome to this edition of SNIA SDC virtual conference. I am Sathyashankara Muguli, the Director for Form Test Engineering and Validation at Micron. I am joined by my colleagues Abhilash and Shiva in this talk. The topic that we would like to talk today is about open standards and how it is opening new possibilities for the ever-growing data storage industry. I would like to get through the agenda of this topic quickly so that you get to understand what you may take away in the next few minutes. I'll start with providing high-level definitions of open standards, then briefly talk about benefits and few guiding principles. After that, I will hand it over to Abhilash and Shiva to take us through to the end of this session, talking through various prominent drivers and then how open standards has evolved over a period of time and some interesting trends around it. Right. So that's the overall agenda for this topic. Okay, let's see what are open standards. WWW, right? Who doesn't know? TCP/IP or HTTP or even PDF for that matter, right? So can you imagine our world today without any of these things? All of these are, the examples of open standards and have been a significant impact to our lives for some time now and continue to do so. They keep evolving and extending all the time. Basically, if you see, standards are nothing but distilled wisdom of highly competent subject matter experts from various organizations working together. So the open in open standards is the ability to freely propose a set of guidelines through proposals and then get it ratified through industry consortium to make it standard. So basically, open standard is open only if it is freely adopted, implemented, or extended. And no one organization or vendor owns it. It's a collective responsibility at the end of the day. So this is a very high level, definition of open standard and very old examples of few of the open standards that we have seen so far. Having looked at what are open standards, let's see what are few benefits of it, right? So the benefits are for all, right? Be it a manufacturer, for a seller, or a buyer, or a trade association, or an end user, or even a regulating body. So it promises collaborative innovation. That means it creates a platform for multiple vendors or organizations or even individuals to come together to drive innovation in a particular area of common interest. So the power of collaborative innovation is such that many times it ends up creating growth of new market or even expansion of the existing ones. Open standards are publicly published, so accessible to all readers. When a product is baselined upon open standards, it's easy for anybody to compare products from more vendors. Since it's easily adoptable, extendable, and promotes collaboration between the manufacturers, it enables rapid market growth in that, in that segment or in that area. And then the interoperability across software, hardware, and overall stack becomes a byproduct of it. No one organization controls, and these standards are formed by cooperation. There is a healthy competition between vendors, and no monopolies observed. And since these standards could be applied globally, it also propels the international trade. Here, we have tried to list only a few benefits of open standards. In the interest of time, there could be many more. In a nutshell, if I have to say, end customer is a winner, as the product that comes out to the market based on open standards is a result of collaborative innovation, distilled wisdom of experts in the industry, and highly interoperable. And of course, it also creates a no vendor lock-in situations. Okay, now before I hand it over to Abhilash and Shiva, let me quickly provide insight into few guiding principles of open standards. Of course, adoption of open standard is voluntary. Few things to highlight in this context are there are no royalty to be paid for the usage of any open standard. It also enables to extend any standard, provided there is a license for all to create, distribute, right? Some may even implement partially to the standard, and the standards body may decline to certify such implementation due to lack of compliance. But they are free to do partial or sub standards implementations. Then the cooperation between the standards organization is very important. They need to mutually respect the autonomy and IP rules of the others. So some of the principles have to be adhered. The due process has to be followed, and it's transparent, and there is a opportunity to appeal against any decisions taken in the standards committee. So the process for periodic standards review is very well defined. Board consensus is important, and it helps in arriving at agreement across range of interests. And the transparency is key here. An advance public notice of proposed standards is available, and there is also a public comments period set for any standards approval before it gets final approved, and it gets on to adoption. As you might have realized, ultimately it's the collective empowerment, be it about technical merit, enabling interoperability, and thereby benefiting humanity in a positive way. So with that, I hand it over to Abhilash and Shiva to take us through to the rest of the session. Thank you.
Thank you, Satya. Hi, I'm Abhilash, and today I'll be talking about the storage open standards and its technology evolution. Who are the drivers? Prominent storage standard organizations. Some of the standards organizations that are prominent in today's industry are SNIA, JDEC, RDMTF, Open Compute Project, and the Open Alliance. SNIA was one of the most prominent organizations which started off as a standard to manage NAS and SAN. Today, SNIA governs more than 10 different technology initiatives, including the computational storage drive, CXL, persistent memory, SNIA Nodefish, and SSD form factors, to name a few. JDEC is one of the standards that are the basic building blocks of the digital economy. Defining the standards for semiconductors, the quality, the reliability, and packaging, JEDEC has been helping the semiconductor industry in a big way. They are also the main standards definition defining the standards for the main memory, the flash memory, etc. DMTF is an industry organization leading the development of standards for management interfaces between the interoperability between the enterprise and the internet environments. OCP, as the name suggests, it brings in a collaboration between different vendors in the space of data center, and this includes the storage standards as well. The Open Fabric Alliance is to deliver a unified cross-platform transport independent software stack for RDMA and the kernel bypass. Coming to the transport protocol, some of the transport protocols that have evolved are the serial attached SCSI, the PCI SIG, along with NVMe Express, which has taken some of the inputs from the SCSI. SCSI was a protocol that was developed and maintained by T10 Technical Committee, also known as the INCTS Committee. The PCI SIG is the governing body for the peripheral component interface consumption, and it has been responsible for developing protocols like the PCI, PCIX, and PCIe. SFF, the SFF committee was formed in 1990, which was basically for defining a disk drive form factor for uh, laptop computers, which has now found its way into the data center. This has been absorbed by SNIA as well. ONFI, the Open and Flash interface, is a consumption of technology companies working to develop open standards for NAND flash interface and the devices that communicate with them. Flashback to current. Let us come to the evolution of the open standards in the storage world, going way across. In neonatal days, different vendors came up with the different non-standard protocols, different types of devices were manufactured, along with various incompatible form factors with each other, which also led to different incompatible infrastructures being in the industry. This led to T10 taking the initiative and in standardizing and collaborating with multiple vendors. Thus began the initial steps towards the open standards, and in 1996, the T10 standards were ratified. In 1992, the PCI-SIG, the Special Interest Group, was formed initially as a compliance program to help computer manufacturers implement the Intel specification. The organization then became a non-profit organization, and it was officially named PCI-SIG in 2000. The PCI-SIG has more than 800 member companies that develop differentiated interoperable products in compliance with the specifications. It has produced PCI, PCIX, and PCI Express specifications. As scalability of the data and the network was becoming a challenge, INCTS, with collaboration with the fiber channel industry, came up with the T11 protocol, the fiber channel protocol to scale the data and the data centers. At the same time, ATA was released by the T13 committee, which went on to become an interface for the hard drives and SSDs. Across 1997, SNIA started developing promoting other standards. Meanwhile, JEDEC, along with IEC and EIA, started making standards available internationally for free. This led to higher industry adoption. DMTF came up with the common information model to enable interoperability and have a common interface for collecting the data across the servers. In 2000, JEDEC published the DDR spec, the JESD79. In 2002, DMTF came up with the ever management of storage devices in multiple vendors in the SAN. So the 2002 JEDEC also standardized the storage device standardization for military and other environments, which has now been adopted by data centers and enterprise storage for storage customers. In 2004, OFS charter was to facilitate the rapid adoption of InfiniBand architecture. Along with that, in 2002, JEDEC published two standards for solid-state drives, the JEDEC 218 and 219, which were part of the SSD requirements and the endurance test methodology, which is still followed up till date. In 2006, a consumption of the technology companies working to develop the OpenNet standards for flash communication was formed. This was announced at the Intel Developer Forum in March 2006.
Hi everybody, my name is Shiva Pava. As we already discussed in the previous slides about all the open standards that actually defined some of the storage protocols, some of the memory protocols, some of the fabric protocols, and flash interfaces. The coming of ONFI actually enabled us to design a product that using which we could directly talk to the flash interface. So NVM HCI initially developed the NVMe specifications, which brought in a way in which a host could talk to a flash interface using the existing PCI SIG or the PCI protocol. This leveraged most of how we could do register access, which was already designed. And they added more host interfaces for us to optimally use the flash interface. Then came UFS through JEDEC and also HBM, which was adopted from AMD, which they wanted to make it available for the broader market. So that was called JESD 235. Then came Redfish, which introduced secure management to data centers called software-defined data center, in which you could talk to almost any device over the fabric securely. SFF had already existed, but then it became an affiliate of SNIA that drove a lot of innovation in different form factors. We'll see a little more about it in the upcoming slides. Swordfish was primarily designed to do storage management. And there was a new management API that was introduced 2017 timeframe. And then there was this, amalgamation of two different big standard organizations coming together and getting the most innovative flash memory technology category award for NVDIMM design. So this was a revolution where two different standards got along for a common cause. And then came SDSFF, which was initial proposal by Intel, but then after it became a part of SFFTA, that is a task association, it became a technology affiliate. And this became a de facto for all the data centers because this would enable us to do the most cost-effective management of flash. So the amount of heat dissipated, the amount of the space utilization was optimized using EDF. SNIA, DMTF, and NVMe came along. So NVMe MI and DMTF already had management interfaces and came under the same umbrella where SNIA started coordinating with all these standards and becoming an liaison for all these protocols. Now, at 2020 came a revolution where multiple different organizations realized that they have a common problem where they had to do CPU coherency and they had to somehow remove the DRAM bottlenecks or DDR bottlenecks. So for that, the CXL consortium actually, along with PCI SIG, Gen Z, DMTF, came up with the CXL 1.0. And there was, ways in which they solved the problem of optimizing the use of Flash by the application space. Right? So this was another revolution where zone namespaces came into picture. In 2020, OCP announced NVMe Cloud SSD specification. This was primarily for cloud workloads, or they had tailored it for cloud use cases. And computational storage started to evolve. CXL 3.0, which used MCTP protocol, right, binding protocol to actually manage devices over Fabric, came along. And HDDs became NVMe 2.0 compliant. So this was a huge step forward. In 2001, Google announced Smart FTL, where they wanted to bring the FTL out of the device and make it more available to the applications to actually control how we talk to NAND flash. There is newer standards that are going to come by. They are called hyperscale boot drive specifications. It's not yet released, but it will come soon. So we would like to summarize all that we have spoken about in this one diagram. So initially there was memory technology that was published by JDEC, and then came storage technologies, which was the governing body was SNIA, and later on there was PCI SIG, SAN, DMDF, which was used to manage the storage or the SAN environments mostly. And then Swordfish came along for doing, further management of storage specific, requirements. Then came Fabric, in which NVMe over Fabric, DMDF became a part of it because there was distributed management needed. ZNS is taking shape inside NVMe Express, where we would be able to directly manage certain zones in the device for a certain particular application workloads. And then came more devices where NVMe started leveraging the host memory. So there was a cross amalgamation between memory and storage, and was using ONFI to be able to talk to the NAND interface in the backend. Then NVMe Express actually and SNIA started developing storage. Computational storage device where we could do computations within the storage as a form of functions, and more computation standards emerged where CXL, OpenCAPI, and Gen Z collaborated together. CXL used the existing DRAM solution, and with the OpenCAPI actually introduced another technology called OMI, where we could increase the memory bandwidth and also the capacity, which was a bottleneck. Right? So we see that there is a lot of cross amalgamation happening, and we are very excited to see what would happen next. So with that, I would like to say that adopting open standards can reduce cost and in the immediate, intermediate, and long term. Open standard adoption means better longevity. So there is going to be a lot of cross-functional standard, and it will continue to emerge. CPU coherency will improve, and CXL is a very good example of it. New host memory standards will emerge. HDD has already adopted NVMe standards, so you can see that how we are making impact in the legacy technology. A DC boot drive will get a new specification. New storage architecture will emerge. New SSD form factor will emerge. RISC-based processors will find home in newer storage architectures. More use case centric storage specifications will emerge, like blockchain data and storage network interoperability. Thank you, everybody, and please take some time to rate us. See you in the next SDC.